Okay, as we discussed, as in the last class, just started types of sets, which was followed by some numericals from an exercise. So first, it was discussed a little bit about empty set. Empty set or null set or void set. So in terms of on the basis of the number of elements on a set, sets are classified. And one of these types is the empty set, and sometimes it is said null set, and sometimes it is known as void set. So, from the literal meaning of the term, you can understand that this is empty. This is empty. That means no element is there. This number of elements in the set, in the collection, it is 0. So that means simply the definition is a set having no element is called empty set or null set or void set. Number of elements is 0. Next, another type, that is finite set or finite set and infinite set. Again, in terms of number, some sets are said to be finite and some sets are said to be infinite. Finite is simply when the number of elements in a particular set is finite, then it is finite set, otherwise infinite. That means number of elements is infinite, then it is infinite set. So here are some examples. Look at the screen here. Example number 5. State which of the following sets are finite or infinite. You see the first one, x such that x belongs to n, that means x is natural, and x minus 1 into x minus 2 is equal to 0. So these are in set builder form, it is given. So x such that x belongs to n and x minus 1 into x minus 2 equal to 0. In this set, two conditions is here. Two conditions are here. Number 1, the element is natural. Second condition, the product of these two factors is 0. So, element is natural, one condition, and another condition is product of this equal to 0. So, from this relation x minus 1 into x minus 2 equal to 0, we have the values of x, 1 and 2. The values of x are 1 and 2. From the second condition, we are getting x as 1 and 2. Again, from the first condition, x is natural. Exactly 1 and 2 are natural. So, in this set, elements are 1 and 2. So, that means 2 elements are here. So, it is finite. Similarly, number 2, x belongs to n, that is x is natural, and x square is equal to 4. So, x square equal to 4 means what will be the values of x? So, values of x will be definitely x square equal to 4 means the values of x will be minus 2 and plus 2. If you put here minus 2 square 4. If you put 2 here, 2 square equal to 4. That means the values of x are minus 2 and plus 2. But first condition is given, x is natural. So, to fulfill the both conditions, natural and second condition, so we will be having only one value of x, that is only 2, because minus 2 is not natural. So from second condition, we are getting two values, minus 2 and 2. But in the first condition, it is mentioned x must be natural. So in this set, only one element is there, that is only 2, not minus 2. Similarly, so finite, only one element, so finite. Third one, x belongs to n, x is natural, and twice x minus 1 is equal to 0. So first condition, from the first condition we can understand, yeah, this x represents only natural number. From the second condition, we can have the values of x. So here from the second condition, we can have the value of x is half, means 1 by 2. So from the first condition, we must have the natural number. Second condition, x is equal to half. So x is equal to half. From the second condition, whatever we get, that is x is equal to half, we cannot include in this set half, because in the first condition it is mentioned x must be natural. So from the second condition, whatever value of x we are getting, that is half, it is not natural. So that means no element exists here. That means no natural number exists which satisfies the second condition. That means twice x minus 1 equal to 0. So no natural number exists. That means no element exists. So number of elements in this set obviously 0. Number of elements is 0. No element is there. So that means finite set. It is exclusively entitled as empty set, null set, or void set. But in terms of finite and infinite, to answer, we must say it is finite set. Empty sets are always finite. Next one, x belongs to n, that is x is natural and x is prime. So x is natural and x is prime. That means collection of all prime numbers. That is collection of all natural prime numbers. So prime number set is infinite. So entire set is infinite. Next one, x such that x belongs to n and x is odd. So x is natural and x is odd. That means collection of all odd numbers, odd natural numbers. Collection of all odd natural numbers, which is obviously infinite. Next, we go to equal sets. Equal sets, we know what is set and how it is represented, and finite set, infinite set, empty set. Now, when two sets can be said to be equal, equality of sets. So on equality of sets, how can you say two sets are equal? So it is very simple. Definitely, observation must be on the elements. If there are two sets and both the sets comprise same elements, and there is no restriction on number of elements. There is no restriction on number of elements. Just it is mentioned as same elements. Because same elements, one particular element might be repeatedly present in a particular set. So in that sense, number of elements might be different. Number of elements on two sets might be different. But whatever elements are there in two specific sets, the elements must be same. Then we say it is equal, and symbolically equal sign, a equal to b. That means if a and b are two sets, we write a is equal to b. In this example, you can see here the screen. Definition is here given. Immediately after a definition, first example, look at the first example. A is equal to A is one set which comprises one, 2, 3, 4. Four elements are here. And next set B which comprises 3, 1, 4, 2. That is order of the elements is different. 1, 2, 3, 4. In another set B, 3, 1, 4, 2. So obviously A equal to B because they comprise same elements. If in A any particular element is written once more, that is repeated, like 1, 2, 3, 4, again 2, then also A equal to B because elements are same. So thus you can say when two sets are equal, we understand they have same elements. Uh, uh, in another example, you can see here, find the pairs of equal sets if any, give reasons. Here A, B, C, D, E, 5 sets are given. So pair of equal sets we can select. A is a set which consists of only one element, that is 0. And B, x such that x greater than 15, that is the value of x is greater than 15, and x less than 5. X less than 5 but x greater than 15. Is there any value which is less than 5 greater than 15? So no value exists, so it is empty set. B is empty set, null set. C, x such that x minus 5 is equal to 0. So it is simply x equal to 5. So C consists only one element, that is 5. No any other condition. One condition only given, x minus 5 equal to 0. That means x equal to 5. So C consists of only one element, that is 5. Again D consists of only one condition given, x square equal to 25. And x square equal to 25. No any other condition is given in this set builder form. Only x square equal to 25 given, from which we have the values of x minus 5 and 5. So two values of x we are getting from this condition, minus 5 and 5. So the set D consists two elements, minus 5 and 5. So E, the last set E, x such that x is an integral positive root of the equation this. So we have to solve this. It is quadratic equation. If we solve this equation, we will have the value, two values of x, and from that two values only positive value we have to consider, an integer positive value, whatever we get from this equation, that will be the elements in this set. Now, obviously, you can say when you know the elements, you can observe whether sets are equal or not. So, obviously, A not equal to B, A not equal to C, A not equal to D, A not equal to A, because A is only one element. A is the set which consists of only one element, that is 0. And very clearly it is not equal with others. So D not equal to B not equal to C, D not equal to B. So all are given here. So it is no problem to write equal or not. Just you have to find out the elements consisted in the set, because sets are defined here in set builder form. So from set builder form you can list the elements, that is in roster form. So from set builder form, if you write in the roster form, then you will know the elements, what elements are there actually. Then you can select which particular sets are equal. And that is the way to think. Again in exercise, a few examples you can pick up from this. Which of the following sets are examples of null set? Null set means empty set. A set of odd natural numbers divisible by 2. Set of odd natural numbers divisible by 2. It is null set or not? Odd natural number divisible by 2. So obviously null set, because odd numbers are not divisible by 2. That is the definition of odd numbers. So no element exists. So 5. Set of even prime numbers. It is not 5. It is not null set, because there is one and only one prime number which is even, that is 2. So 2 is there. So it is not null set, not empty set. Single element is there, and that is 2. And here again, x is natural numbers, x less than 5 and x greater than 7. So x less than 5 and x greater than 7, x is a natural number. Can you have any number which is less than 5 but greater than 7? Less than 5 but greater than 7, and that is natural number. So definitely no elements exist, so the set is empty. Why such that y is a point common to any two parallel lines? So this set definitely empty set, null set, because no common point exists. No common point exists between two parallel lines, because parallel lines means they are not intersecting. If two lines do not intersect, so common point does not exist. Which of the following sets are finite or infinite? From the definitions of finite and infinite set, as I explained, you can observe it from yourself. Very simple. The set of months of the year is finite or infinite. Obviously finite. 1, 2, 3, dot dot, that is natural numbers are given within second bracket here. So inside roster form, it is written 1, 2, 3, 4, dot dot, up to infinity definitely. So it is infinite set. A number 3, 1, 2, 3, 4, dot dot, so on up to 100. Upper limit is there. So the elements from 1 to 100, so it is finite. The set of positive integers greater than 100, infinite number of positive integers are there, so it is infinite. The set of prime numbers less than 99, so obviously it is finite. So that whether it's of the following set is finite or not. Similar example about finite or infinite, the set of lines which are parallel to x-axis, infinite. Because infinitely many lines you can consider, you can imagine parallel to x-axis. So infinite. The set of letters in the English alphabet. So 26, everybody knows that is finite. The set of numbers which are multiple of 5. So infinite. Multiples of 5. Multiples of 5. So it is infinite. Infinitely many numbers are there which are multiples of 5. So it is infinite. The set of animals living on the earth. So set of animals, so how many animals are there exactly living on the earth? It is difficult to study appropriate number. It is very difficult, but after all, it is a number. Definitely, it is not infinite. So we human race, it might be possible, might not be possible to count exactly what number of animals are living on this planet. It doesn't mean it is infinite. It is not infinite. We can count, we can't count, doesn't matter. So after all, it is definitely uh, finite. The set of circles passing through the origin, infinite, because through origin, infinite number of lines we can draw. So infinite lines means obviously we can draw, we can consider infinitely many number of circles to the origin. So it is obviously infinite. In the following state, whether A equal to B or not. So very simple. You can try from your side. As I told you, this textbook you should follow and no any other text required. I am giving you the sessions based on only this book one, and you just follow up this book then you do not have any problem. And whenever you get any question on these lessons, on these chapters, if you go parallelly with the session, then definitely it would be very comfortable for you. And even after that, also, whenever you face any problem and you can any numerical, so you can communicate it. So just you can any other materials required to understand through this. Are you saying? Are you saying something? Is anybody speaking? Okay. I do hope this exercise you will do yourself. Whatever left, very few questions are left here. Definitely, you can try yourself. And fundamentally,
Okay, sir.
I do hope you have understood this. Subsets. When a set is said to be subset, and how it is represented based on subsets, we will be discussing later on in the next class. Okay.
Yes, sir.
Okay, from the next class, I
Yes,
will start subsets. Okay, okay. Thank you so much.